Class 7 Science Chapter 14 Electric Current and its Effects. Animated Science Introduction. In Class 6, you have learnt about electric circuits. Let's recall the conditions that are required to make an electric current flow in a circuit. Look at the following circuits and tell which one is a complete circuit. As you can see, circuit 1 is incomplete as the path is broken, that is, wire is not connected properly to one end of the bulb. In circuit 2, there is no battery, so it is also incomplete circuit. Circuit 3 is a complete circuit with all the components, that is wire, bulb, cell, connected properly. In this case, the bulb glows. So we can say that there are three conditions that need to be fulfilled for the electric current to flow: a source, an unbroken path, and a metal wire. Now, in this chapter, let's learn more about electric current and its effects. Electric current. Electric current is any flow of charge, usually through a metal wire or some other electrical conductor. A conductor is a material that conducts electricity. That is, electric current can pass through it. Materials such as copper metal conduct electricity. The ampere, as in symbol A, is the SI unit of electric current. Electric circuits. A closed path formed by the interconnection of electrical components through which electric current flows is called an electric circuit. This is an electrical circuit consisting of a cell, a bulb, wire, switch, and a conductor. Cell, switch, wire, bulb. Symbols for some basic electric components. Some common electric components can be represented by symbols. In Table 1, some electrical components and their symbols are shown. Switch in on position. The bulb glows if the switch is in the on position. Switch in off position. The bulb doesn't glow if the switch is in off position. Battery. The combination of two or more cells is called a battery. In a battery, the positive terminal of one cell is connected to the negative terminal of the next cell. In certain devices, the arrangement of cells is one after the other, as shown in the figure A and B. However, in certain devices, the arrangement of cells is side by side, as shown in the figure C. In this kind of arrangement of cells, there is usually a thick wire or a metal strip connecting the positive terminal of one cell to the negative terminal of the next cell, as in figure 3. In order to help you to place the cells correctly in the battery compartment, plus and minus symbols are usually printed there. Many devices such as torches, transistors, toys, TV remote controls use batteries. The batteries used in tractors, trucks and inverters are also made of 3 cells. Therefore, it has 3 pairs of long and short parallel lines, as shown in the Table 1. Wire. A wire is made of a conducting material such as a metal. Metals are conductors of electricity. Cell holder for cells. The cells are placed in the cell holder in such a way that the positive terminal of one cell is connected to the negative terminal of the next cell. A wire is connected to the 2 metal clips on a cell holder as shown in the figure. The battery is now ready for use. Cell holder for 2 cells. How circuits work. For circuits to work, the circuit should be complete. That is, path of flow of current should not be broken or incomplete. Open circuit. If the switch is in the off position, the current does not flow through the circuit. Then it is said to be an open or incomplete circuit. Closed circuit. If the switch is in on position, the current flows through it. Such a circuit is said to be a closed circuit or complete circuit. Heating effect of electric current. Heated element of an electric room heater. Heated filament of a bulb. Heated element of an electric toaster. Heated element of an electric iron. When an electric current flows through the filament of a bulb, it generates heat and so the bulb becomes hot. This property is named the heating effect of electric current. Every day we use many appliances that work on the property of the heating effect of electric current. For example, the electric room heater, electric roti maker, electric iron, toaster, hair dryer, electric stove, immersion water heater, food warmer, electric coffee maker, electric rice cooker, and geyser. Work on the property of the heating effect of electric current. These appliances have coils of wire that produce heat, which are known as heating elements. As current flows through these electrical appliances, the coils of wire inside turn bright orange-red in color. This is because a huge amount of heat is produced. This kind of heating is called ohmic heating or Joule heating. The amount of heat produced in a wire depends on its material, length and thickness. Electric fuse. The electric fuse works on the principle of the heating effect of electric current. A fuse is a safety device used in an electric circuit. It is used to limit the current in an electric circuit. The use of a fuse is to safeguard the circuit and prevent fires. You know that electrical appliances work when an electric current passes through them. But what happens when a large amount of electric current passes through an appliance such as an electric iron, refrigerator, television, or a hair dryer? If a large amount of current is drawn inside an appliance, it causes the wires to get overheated and the appliance gets damaged. This happens as a result of some fault in the circuit and can be extremely dangerous as it can lead to fire. Hence, to prevent the electric appliances from getting damaged due to excessive passage of electric current through them, a fuse is used. In case the electric current passing through the circuit exceeds the safety limit, the fuse wire present in the fuse gets overheated and melts, thereby breaking the circuit. Types of electric fuses. Ceramic fuse. It is made of porcelain or ceramics. It consists of a fuse holder, a fuse grip, two terminals and a soft metal fuse wire connected to them. This fuse is used in buildings. Cartridge fuse. It is a small glass tube of 3 cm long with a metal cap on each side. The fuse wire is placed inside the tube. This fuse is used in electrical appliances. Miniature circuit breakers or MCB. Nowadays, another kind of fuse commonly used in our homes and factories is miniature circuit breakers or MCBs. These are made like a switch which automatically turns off when the current in the circuit exceeds the safety limit. You can later on turn them on again to complete the circuit. Magnetic effect of electric current. When electric current is passed through an electric wire, it creates a magnetic field around it, which deflects the magnetic needle. This property is the magnetic effect of electric current. Let us understand this with a simple experiment. Take the cardboard tray from inside a discarded matchbox. Wrap an electric wire a few times around the cardboard tray. Place a small compass needle inside it. Now, connect the free ends of this wire to an electric cell through a switch as shown in Figure 1. Note the direction in which the compass needle is pointing. It points to the north-south direction. Bring a bar magnet near the compass needle. We observe that the needle of the compass deflects in the presence of a magnet. Now, while watching the compass needle carefully, move the switch to the on position. When electric current passes through a wire, it behaves like a magnet. This deflects the magnetic needle. This is the magnetic effect of the electric current. In fact, an electric current can be used to make magnets. Electromagnet. An electromagnet is a type of magnet in which the magnetic field is produced by the flow of electric current. The magnetic field disappears when the current is turned off. Let us see how an electromagnet is made. Take around 75 cm long piece of insulated, that is plastic or cloth covered or enameled flexible wire and an iron nail, say about 6 to 10 cm long. Wind the wire tightly around the nail in the form of a coil. Connect the free ends of the wire to the terminals of a cell through a switch as shown in figure. Place some pins on or near the end of the nail. Now switch on the current. The nail gets magnetized and attracts the pins. Therefore, all the pins cling to the tip of the nail. Now switch off the current. When the electric current is switched off, the current stops flowing through the coil and the iron loses its magnetic effect and hence all the pins immediately fall down. Hence, the iron nail in the experiment gets magnetized when electric current is passed through it. We call this nail an electromagnet. The strength of the electromagnet depends on the number of turns of wire around the core and the amount of current passing through it. Uses of electromagnets. Cranes use electromagnets to lift magnetic material, that is, pieces of iron, nickel, etc. from the junk. The end of such a crane has a strong electromagnet attached to it. Doctors use tiny electromagnets to take out small pieces of magnetic material that have accidentally fallen in the eye. Many toys also have electromagnets inside them. Electromagnets are used in electric fans, electric motors, electric bells, etc. Electric bell. An electric bell has an electromagnet in it. Let us see how it works. The circuit of an electric bell consists of a coil of wire wound on an iron piece. The coil acts as an electromagnet. An iron strip with a hammer at one end is kept close to the electromagnet. There is a contact screw near the iron strip. When the iron strip is in contact with the screw, the current flows through the coil, which becomes an electromagnet. It then pulls the iron strip. In this process, the hammer at the end of the strip strikes the gong of the bell to produce a sound. However, when the electromagnet pulls the iron strip, it also breaks the circuit. The current through the coil stops flowing. The coil is no longer an electromagnet. It no longer attracts the iron strip. The iron strip comes back to its original position and touches the contact screw again. This completes the circuit. The current flows in the coil and the hammer strikes the gong again. This process is repeated in quick succession. The hammer strikes the gong every time the circuit is completed. This is how the bell rings.